Okay, this lesson involves applying the exponent properties and involving products. So this whole chapter is actually about exponents. So whenever we start with this one, let's get my pen up here. Okay, when you start with this one, whenever you talk about a squared times a cubed, what does that really mean? It means that you have a times a, that's your a squared, and then you have a times a, which is your a cubed. So really, whenever you have these two a's and these three a's, how many do you have altogether? So you have 5 a's, and you got that from 2 a's and your 3 a's. So a squared times a cubed is actually a to the 5th. Let's move down here a little bit. So there is a product of powers property that basically just says whenever you have like bases, so both of them being a's, so a to the m times a to the n is equal to the a to the m plus n. So that sounds a little funny, so let's put it with normal numbers. 5 to the 6th power times 5 to the 3rd power. The bases are the same. These bases are the same. So whenever the bases are the same, you can simply add the exponents. So that would be 5 to the 9th power. Okay, coming down here to example 1. I've got 7 to the 3rd times 7 to the 5th. Add them together. 7 to the 3 plus 5 is 8. This one, again, it's worth saying again that the bases have to be the same. So if the bases are the same, you can simply add the exponents. This one has 9. There's no exponent being shown right here. So anytime that you don't see an exponent, you assume it's a 1. So I've got 9 to the 1st times 9 to the 8th times 9 to the 2nd. So I have 1 9, 8 more 9s, 2 more 9s. So 1 plus 8 is 9, plus 2, 11. 9 to the 11th is our answer. Next one. Negative 5 times negative 5 to the 6th. Again, anytime you don't see an exponent, you assume it has an exponent of 1. These bases are the same. So because the bases are the same, I can add the exponents. Negative 5 to the 1st power, negative 5 to the 6th power is negative 5 to the 7th power. Now, you may be wondering why these are in parentheses, and that just has something to do with that. It's the whole entire parentheses being taken to that exponent, and there'll be more on that later in this lesson or later in the chapter. So, again, x to the 4th times x cubed is x to the 4 plus 3, so x to the 7th. So looking down here at guided practice, I have 3 squared times 3 to the 7th. So my bases are the same. So my answer, 3 to the 9th. Next one, 5 times 5 to the 9th. I do not see an exponent there, so I assume it's a 1. 5 to the 1st times 5 to the 9th. 5 to the 10th. Number 3, negative 7 squared times negative 7. Once again, we do not see an exponent. We assume it's a 1. They have like bases, so we can add the exponents. That would be negative 7. Make sure you put it back in parentheses. Negative 7 to the 3rd power. And the last one, number 4, x squared times x to the 6th times x. Once again, we do not see an exponent, so it is a 1. So we've got 2 plus 6 plus 1 would give us x to the 9th. So again, this can only happen if the bases are the same. So if they both have 7s. If this happened to be like 5 to the 6th times 3 to the 4th, you couldn't do anything with that as far as a shortcut for finding out what the exponent is. Okay, let's move on. There we go. Now, there is a difference whenever you're not just multiplying like bases, but you're taking a power to a power. When you take a power to a power, you have to multiply them, because basically what is this saying right here? This says that this is a squared and you have 3 of them. So a squared and you have 3 of them. So you have 1, 2, 3, which means I have 2 A's, 2 A's, 2 A's. Altogether, how many A's do I have? 6. Now there's a shortcut on how to get that. How would you get 6 out of 2 and 3? Well, you'd have to multiply it. 2 times 3. So a to the 2 times 3, so a to the 6th. So there is a multiplication rule that we just learned on the previous page, that whenever they have like bases, you can add the exponents. That would be x to the, x to the 6th. But now if you have something and you have x squared and you're raising that to a power, you're no longer going to add these, because this is saying you have 4 of these. So this would be 4 sets of 2. So this one would be x to the 8th. So there is a distinct difference between there. So just make sure to try and keep those straight. All right, looking down at the next example. Okay, 2 to the 5th times 2 to the 5th raised to the 3rd power. So you have to multiply your exponents. 2 to the 15th. X squared raised to the 4th, so it's 2 times 4, x to the 8th. This one, -6 squared, and you're raising that to the 5th power, so you've got 5 of these, so 5 sets of 2 is 10, so you've got -6 to the 10th power. This one, it looks a little bit different. It's really not. It's everything inside of these parentheses are raised to the 6th power. And all of that is squared. So I've got 2 sets of these. So that's the reason why that is a 12. So it's y plus 2 to the 12th. Make sure that those parentheses stay in there. So simplifying these expressions. I'm raising a power to a power, so I multiply 4 to the 14th. This one, I've still got -2 to the 20th. Come on, to the 20th. Next one, into the 18th power. And the last one, it's really no different, even though it looks a little bit more complicated. It's still m to the 1st to the 20th power. M to the 1st to the 20th power. Okay. Next one, they're talking about power of a product right here. So power of a product. Whenever you have 2 things in here, it's actually this goes to everything. So this is AB cubed, which means it's AB times AB times AB, which really, how many A's do you have? 3, and then you have 3 B's. So it really goes to everything. There are 3 A's in there and 3 B's in there, so that's why it's A cubed, B cubed, if you're going to simplify that out. So let's look down here. Power of a product property. So just like what we just talked about it, whenever there's 2 things inside of here, it's actually everything being raised to that power. So if it's 23 times 17 to the 5th, that's actually 23 to the 5th times 17 to the 5th. Okay, on page 491, example 3, use the power of product property. So again, 2 things inside of here, 8 goes to both of them, so it's 24 to the 8th times 13 to the 8th. This one, 9xy squared means the squared, if you almost want to think of it like a distributive property, it goes to everything. The 9 is squared, the x is squared, the y is squared. 9 squared, x squared, y squared. So you square what you can. 9 squared is 81, x squared, y squared. This one, it is negative 4 squared, and it's z squared. Negative 4 squared is negative 4 times negative 4, which is why it's a positive 16, z squared. Now this one is a little bit different because if you notice, this minus sign is not inside of these parentheses. So this minus sign is not being squared. So you just kind of bring it along to the next step and say, okay, it's actually 4 squared times z squared, which is what we've got here. Whenever we bring it over, it's 4 squared times z squared. 4 squared is 16. Z squared is, of course, z squared. And my negative, I'm just going to bring it along. So that's the reason why my answer on this one is negative 16 z squared, as opposed to this one where it was positive 16 z squared. And again, the reason why the other one was positive is because the negative sign was inside of those parentheses. Okay? Example 4, using all three properties together. So, this cubed right here is only on that x. So that means this squared goes on the 2, and this squared goes on the x cubed. So, I've got 2 squared, which is 4, and I've got x to the 3rd squared, which is x to the 6th. Now, there's also this extra times by x to the 4th out here. So when I've got my 4 times x to the 6th times x to the 4th, these two have like bases, and when you're multiplying like bases, we add the exponents, and that's where we get our final answer of 4x to the 10th. And I believe that's all we've got on here.